Today I'm working with a student on long division. We have a worksheet with 20 problems that we are going to work through together. And he has been doing this in class, so he knows how to long divide. It's just kind of extra help. So, student, if you want to start with the first problem.
What do I do after that?
What do you do after that? Okay. Well, let's make sure, what number do you have this 2 above? It's kind of in the middle between your 3 and 8, so what number should that go above?
3.
The 3?
Yeah.
Okay, so do you want to kind of erase it and make sure that it's right above the 3 so that we know, what does that 2 represent?
23.
It represents 23?
No, it represents how many times 8 goes into 23.
It goes into 23, so that is how many, what's the place value of this? 2 1s, 2 10s,
2 8s.
Well, 2 8s, but it's above the 10 spot, right? This becomes our 10s, correct?
Yeah.
Okay, so if 8 goes into 23 2 times, 16, correct?
Seven, and then bring down the 8. 8 goes in. 9 times 7 is 72, and that 6.
Okay.
29 remainder 6.
There's 6. And how did you know that your 8 needs to be brought below? Brought down to make.
Because 7 can't go into 8.
Because 7 can't go into 8. Good job. You want to start on problem number 2?
9 goes into 37 4 times. 4 times 9 is 36. 6. 9 goes into 16 once. 1 times 5 is 9. 16 minus 9 is
You can use your fingers to count.
7.
7, yep.
4 your remainder 7.
Remainder 7, yes. So now let's try 7 divided by 123.
7 goes into 12 once. 7, 5, bring down the 3. 7 goes into 53. 7 times. 7 times 7 is 49. Subtract, you get 13 minus 9 is 4. And 4. So 17 remainder 4.
Good job. Let's work on this last one.
6 goes into 21 3 times. 3 times 6 is 18. Subtract 3. Bring down the 9. 6 goes into 39 5 times.
You tell me.
6 times.
6 times, yep.
6 is 36. Plus 3. 36 remainder 3.
Okay. We have decided to move into the next lesson of the student's book because the previous worksheet was a little bit too easy for him. So we're going to focus on something that he is new to and will be a little bit more challenging for him. So we are going to use partial quotients to divide. Do you know what partial quotients are? So partial quotients are quotients that you get from dividing parts of the problem. So if you add up all of the partial quotients, you will get the full answer to the problem. So as in this example, you have 18 and they said that 18 could go into 236 180 times. And they got that answer by taking 18 times 10. So 18 times 10, 10 would be your partial quotient right there, because that is what you multiplied 18 by. Do you understand a little bit better?
Yeah.
So then further down, they had a remainder of 56. So 18 can go into 56 2 times, because 2 times 18 is 36. So what would be your partial quotient in this problem? 2 times
2?
18. 2, yeah. So they have the 10, they have the 2. So then they had a remainder of 20, and 18 can go into 20 only once. So 18 times 1 is 18, so what would be your partial quotient in this problem?
1.
1, yep. So then what they did was they added 10, 2, and 1, all the partial quotients, and they got 13, and they finished subtracting, and they still had a remainder of 2. So what do you think you have to do with the 2?
Put it as a remainder.
Put it as your remainder. So let's start with problem number 2, and we can work through this together. So we're not going to write anything on top of the line because we're working to the side of it. See how they work to the side of it?
Yeah.
Okay.
So 36 goes into 54 once. So we put a 1 there.
Yeah, you can put 1 times 30.
30. And that equals 30.
Well, 1 times what number are we multiplying to get to?
30? Oh, 36.
36, yeah.
So do I put equals or anything, or just leave it?
No, you don't have to put
Okay.
equals, but you need to correct your 30 because it's 36.
We do, so it goes in once.
Well, remember we're not writing anything on top of the line.
So 1 times 36 equals 36, and subtract
So you can subtract
54 minus 36, and that equals 18.
Okay, and now what are you
And
going to
so
do?
you put 30, wait,
You're a little bit confused, aren't you? Okay, so I kind of just let you work through that to see that you would get in a little bit of a pickle right here, because you have to take the whole number of 36 and put it into 540 instead of 54, because you have 2 digits here.
you see how many times 18 can go into 36?
Well, we have to see how many times 36 can go into 540 altogether. So that's a big number, right? So
Do you bring down the 0?
well, we can't bring down the 0 because you see how, let's just look at a surface level of this. You said that 36 can go into 540 once. So we should have, what's 540 minus 36?
504?
504. So let's look at this. If we continued what we were doing and you dropped your 0, what number would you get right here?
180?
Yeah, so is that equal to 504?
No.
No. So we need to erase and redo, and we gotta restart what we're doing.
What, the entire thing?
Yeah, you can just erase the entire thing. So, like I said, we have to look at it as a whole number. So, do you see how they just took their 18 times a 10, because that's just like an easy number to work with, like a 0 at the end. So, do you want to start with taking 36 times 10? And maybe we can work from there.
360?
Yeah, so remember we have to write our 36 times 10 to the side so that we can use our partial quotients later on. 36 times 10?
360.
360.
So now do we subtract
Now
that?
you can subtract.
Eight. 180.
Okay, so now we have our 180. So we have the 10 right there, and so now we need to create a line to make sure that we understand that our 10 was our partial quotient in that problem, that part of the problem.
So, or 10?
Yeah, and you can just write the 10 out like that, if that helps you visualize it better. So now let's think of a number that we can multiply 36 by to get closer to 180. 5, let's just do a little bit. Let's there's 5, 0, 3. I think 5 might be a little bit too much. How much? It's perfectly 180?
Yeah.
Then there you go. Good job. Good math. You thought quicker than me.
So is 5 our partial quotient?
So we would have to write what?
5
on this
times
side?
36.
5 times 36, and then yes, 5 would be our partial quotient.
So then, do we add them together?
Well, hang on, we're not finished yet. So our 5 times 36 gave us what answer?
180.
180.
So do we
So
subtract
now we finish
those?
subtracting.
0.
So that means that we have what? If we have zeros over here, that means we have no
Remainder.
remainder. So now we just
So
need to
we
add
add
our far right column.
16.
Well, remember this 1 times 36 was from our previous problem. So we still need to erase that.
So do we just do 15?
15, because how did you get that answer?
Because 10 plus 5 equals 15.
Yes, 10 plus 5 equals 15. We're going to begin working with one last problem on partial quotient division. So let's start, and you tell me what you would first do with this problem. What's the first step?
27 goes into 62.
Well, remember, we have to take it. Remember how we did on this last problem? You took it with only the first two numbers, and it led us to a little bit of a different place, right?
Oh, so how many times? 2 goes into 6?
No, 27 goes into
6?
624. We have to look at the
Oh.
whole number again, remember?
27. I'm not sure.
You're not sure. Okay, so let's look at this problem. This problem, we just multiplied it by 10, right? Because that was an easy number to work with.
10?
You could multiply it by just 10 if that's what you want to start with.
I'm going to do it times 10.
Okay.
So 240?
Remember, we don't write on the top of the line, we gotta write to the side.
240.
Okay.
And then,
Well, is it 240? 27 times 10?
oh, I mean 270.
270.
Okay, so then we subtract those and we get 4 minus 4, 6, 5, 12 minus 7 minus 5. And 5 minus 2 is 3. So 354.
Okay, and let's write our line right now so that we don't get confused about what our partial quotient was right there.
It's 10.
Our 10, okay. So you got this 354 by just your basic subtraction
Yep.
of your quotient, partial quotient right there, which is your 10 times 27 and your 10. So let's look at, again, how many times 27 can go into what number now? Are we
354.
354, that whole number.
50. 15.
15?
Yeah.
You think that big of a number? Let's see. He's multiplying on the side of his paper to try to figure out if 15 times 27 will be small enough to go into that number.
It would be 382. So
that's
if I go down,
That's a little bit too big, right?
yeah.
Okay.
I'm gonna try 27 times 13.
13? Okay.
7 times 3 is 21. No, whoops.
Gave the wrong number at the bottom. So carry 2 times.
7 times 27, 8, 9. And 2 times 3, carry. 2 times 3 is 6. 2 times 1 is 2. 260 plus 91 would be 351.
351.
So that would work.
That's just under 354.
So it would be 13 times 27. And 13 is our partial quotient.
And 13 is the partial quotient. Good job.
And then
Well, remember we have to finish subtracting
and then
this.
the 27, that would 351. And you subtract those. 4 minus 1 is 3, 0, 0. So it would be, I'll add those together, and then 3 is my remainder. 23 and remainder 3.
Good job. And do you see how we could have also taken from the beginning? We could have taken 20 times 27 because you see how you have two tens
yeah.
here? So we could have taken 20 times 27 and then 3 times 27 and then added the same. But you still have 2 steps. So thank you for working with me today, student.
Welcome. Thank you.
You're gonna